In this video, we're going to talk about dividing polynomials as well as we're going to look at two theorems called the remainder and the factor theorem. When it comes to dividing polynomials, there are two ways that we are going to be looking at to doing that. The first method that we're going to look at is called long division, which is something that you may already be familiar with. And then the second method that we're going to look at in this video is something called synthetic division. Now, we're going to start with long division. Before we do an example, though, that involves polynomials, I just wanted to do an example where I show you or I remind you how long division works, okay? For a lot of you, it may have been a while since you've had to do this on paper or by hand, so I wanted to remind you how we do long division. So to begin with, we're just going to be dividing two numbers. So I'm going to be dividing 2273 by 5. So the way we're going to do this is I'm going to set it up like this. So 2273 goes inside and then 5 goes outside. So next I'm going to try to figure out, so I'm going to see, does 5 go into 2? 5 does not go into 2. So then we're going to look at the next number, which is another 2. So we're going to see, does 5 go into 22? 5 does go into 22. 5 goes into 22 4 times. So what I'm going to do is I'm going to put a 4 up here. And then I'm going to multiply 4 times 5. 4 times 5 is 20. So I'm going to write 20 underneath the 22. And then what I'm going to do is I'm going to subtract them. Okay, you always subtract. So 22 minus 20, that's going to give me 2. After I subtract these, next I'm going to bring down the 7. So now I have 27 down here, and I'm going to see, so does 5 go into 27? 5 goes into 27 5 times, so I'm going to put the 5 up here, and then I'm going to multiply 5 times 5. 5 times 5 is 25. I'm going to write the 25 underneath the 27, and I'm going to subtract those two numbers. 27 minus 25 is 2. After I subtract them, I bring down the next number, which is the 3. So now I have 23. I'm going to see how many times does 5 go into 23. That's 4 times. So when I multiply 4 times 5, that's 20. And then I subtract 23 minus 20, that's going to give me 3. Now there are no other numbers for me to bring down, so this is where I'm going to stop. Okay? So before I write down my answer, this number that I have left down here, we call this number the remainder. Okay, and then up on top, the 454 is called the quotient. And then the 5 is what we call the divisor. So when it comes to writing down our answer here is going to be 454, which is the quotient. And then if we have a remainder, we're going to put the remainder over the divisor. So in this case, that's 454 and 3/5. That's how I divide numbers using long division. Now, the same process of long division, I'm now going to apply that to dividing polynomials. So remember, polynomials are functions that have several terms in them, and we're interested in dividing them. Now, before we can divide, there are two things that we need to check before we do the division process. The first thing is we need to make sure the terms are arranged in descending powers of x. So what I mean by descending powers of x is you have to have the largest power first, and then you go down from there. Okay, so you want to go from greatest to least, like it says, or from the largest power down to the smallest power. So that's the first thing we have to check, is make sure the powers are arranged properly. Next, we also have to make sure that there aren't any missing powers. If there is a power on the x that's missing, we have to put a 0 there. as a placeholder. You will see what I mean by that when I do this next example. So here I would like to divide 4x cubed minus 23x plus 3 by 2x minus 5. So my polynomial is 4x cubed minus 23x plus 3. So before I set this up to do the division, we need to check two things. So first we have to make sure the powers are arranged properly from the largest power down to the smallest power. And then we have to make sure that there aren't any missing powers. So my polynomial is 4x cubed minus 23x plus 3. So the first term is x cubed. And then you notice that there is not an x squared term in this function. So because I don't have an x squared term, I'm going to have to add an x squared term. And then I'm going to write it as 0x squared. Okay, so it's going to be 4x cubed plus 0x squared, and then minus 23x plus 3. Okay, and then I'm going to divide this by 2x minus 5, which was the divisor, so the 2x minus 5 goes in front. Now here's how we're going to do this. So similar to how we did the long division with the numbers, we're going to do it the same way here. So here, I'm going to look at my first term that I have inside of the division, which is 4x cubed, that's the first term. And then the first term that I have in the divisor. In the divisor, the first term is 2x, okay? So what I have to see is I need to figure out what do I need to multiply by 2x to get 4x cubed. Okay, again, what do I need to multiply by 2x to get 4x cubed? So I have 2x to get 4, I need to multiply the 2 by another 2. And then I have an x to become x cubed, I need an x squared. Okay, so I need to multiply by 2x squared. So whatever it is that I need to multiply it with, that's what I'm going to write above here. Okay, so we said 2x squared, so I'm going to put the 2x squared up here. Okay, so now you will see when I multiply 2x squared times 2x, that's going to give me 4x cubed. So that's what I'm going to do. I'm going to multiply 2x squared times 2x. That's going to give me 4x cubed. And then 2x squared times negative 5 will give me negative 10x squared. What I'm going to do now is I'm going to subtract these. Okay, now the thing you have to be careful about here when you're subtracting is you're subtracting all of this. That means that you're going to have to distribute the negative to both of these terms. Okay, so I'm going to put a little note here where you're going to have to distribute the negative. So what's going to happen when you distribute the negative is that this negative is going to change into a plus. Okay, so this will become a minus, and then this will become a plus. So now when I combine 4x cubed minus 4x cubed, those are going to cancel. And then it's going to be 0x squared plus 10x squared. So 0 plus 10 is going to be 10x squared. That's what I get when I subtract these. After I subtract these, what I'm going to do next is I'm going to bring down the next term. So I'm going to bring down the minus 23x. Now I'm going to do this again. So again, out here I have 2x. Now what I have down here is 10x squared. I need to figure out what do I need to multiply by 2x to get 10x squared. So I need 5x. So I'm going to put the 5x up here. And then I'm going to now multiply 5x times 2x. That's going to give me 10x squared. And then 5x times negative 5 will give me negative 25x. Again, I'm going to subtract. When I subtract, I have to subtract all of these two terms, meaning I have to distribute the negative. So when I distribute the negative, this will become negative, and this negative will change into a plus when I distribute it. So 10x squared minus 10x squared are going to cancel out. Negative 23x plus 25x, that's going to give me 2x. After I've subtracted these, next I'm going to bring down the plus 3. And then I'm going to repeat this process. So now I have a 2x. And out front, I also have a 2x. So I need to figure out, what do I need to multiply by 2x to get 2x? Well, that's just going to be a 1, because 1 times 2x is 2x. So I'm going to put that here. And then I'm going to multiply the 1 times the negative 5. That's going to give me a negative 5. I'm going to subtract these. When I subtract them, I'm going to have to distribute the negative. So this will become a minus here, and then this minus will change into a plus. The 2x terms are going to cancel. Then I have 3 plus 5. 3 plus 5 is going to equal to 8. I have nothing else to bring down, so this is where I'm going to stop. The 8 is what we call the remainder. So now here is how we're going to write down our answer. Okay, so our answer is going to be the quotient, which is what I have on top, 2x squared plus 5x plus 1. And because I have a remainder, like I discussed earlier, what we do when we write down our answer is we have to put the remainder over the divisor. So in this case, I'm going to write down the 2x squared plus 5x plus 1, and then I'm going to add to that the remainder, which was 8, and that's going to go over the divisor, which was 2x minus 5. So the remainder is the only thing that goes over the divisor. That's my answer. This is what I get when I divide 4x cubed minus 23x plus 3 by 2x minus 5. Here's another example where I have to do long division. I'm given this function here, this polynomial, 1 minus 7x plus 5x squared minus 3x cubed plus 2x fourth. And I would like to divide that by x squared plus 3. So like we said earlier, what we need to do first is there are two things we have to check. We have to make sure first that the powers are arranged properly, and then if there are any missing terms or missing powers, we have to put a 0 for it. In this case here, you will see that I have to rearrange my terms. So when I rearrange my terms, that's going to give me 2x power 4 minus 3x cubed plus 5x squared minus 7x plus 1. There aren't any missing powers in this case. It was just a matter of rearranging everything, which I've done here. And that's going to be divided by, the divisor is x squared plus 3. All right. So now we're going to start the process of long division. So how do we do this again? You're going to look at the first term you have inside and the first term you have outside. Inside I have 2x power 4, outside I have x squared. So what do I need to multiply by x squared to get 2x power 4? I need to multiply it by 2x squared. Okay, so whatever it is that you need, that's going to go on top here. Now, one of the things that I didn't tell you guys earlier is that when you write it down, for instance, so we decided here that we needed 2x squared, so that when I multiply 2x squared by x squared, that's going to give me 2x power 4. Notice where I wrote the 2x squared, I put the 2x squared above where the 5x squared was. Whenever you do long division, you want to make sure that you aligned all your terms properly. So all the x power 4 have to be aligned properly, all the x cubes have to be aligned properly, all the x squares have to be aligned properly, and so on. So that's why I put the 2x squared above the 5x squared. All right, so now I'm going to multiply 2x squared times x squared. That's going to give me 2x power 4. Next, I'm going to multiply 2x squared times 3. Well, 2x squared times 3, that's 6x squared. Okay, so you have to be careful where you're going to put the 6x squared. I'm not going to put it right here because this is underneath the x cubed terms. Okay, so if I put it here, then I'm not going to be able to subtract them. You need to put the x squared underneath where all the x squares are. So 6x squared is actually going to go right here. Okay, and it's going to be positive. So notice where the 6x squared was underneath the 5x squared. All right, I'm going to subtract these. When I subtract them, I have to distribute the negative. So that's going to be negative 2x fourth and then this plus is going to change into a minus. When I combine them, the 2x fourths terms are going to cancel. The negative 3x cubed, there wasn't any x cubed terms that got subtracted from it, so that's just going to remain as negative 3x cubed. And then I have 5x squared minus 6x squared. That's going to give me negative 1x squared, or just negative x squared. So I subtracted these. After I subtract them, I have to move down the next term, which is a negative 7x. So I'm going to put minus 7x right here. All right, now I'm going to repeat this process. Here I have negative 3x cubed. Out here I have x squared. I need to figure out what I need to multiply by x squared to get negative 3x cubed. So I need a negative 3x. So I'm going to put the negative 3x over here above the 7x. Next, I'm going to multiply negative 3x times x squared. That will give me negative 3x cubed. And then negative 3x times a positive 3. That will give me negative 9x. I'm not going to write the 9x underneath the x squared. Instead, the negative 9x will go underneath the 7x, so that now I can subtract them. When I subtract my terms, I have to distribute the negative, so this minus will change into a plus, as well as this minus will change into a plus. The negative 3x cubed terms are going to cancel. There wasn't an x squared term that we subtracted, so that just comes down, and then negative 7x plus 9x will be positive 2x. So I've subtracted these. After I subtract them, I bring down the next term, which is a plus 1. Again, we're going to do this. So here I have negative x squared. Out here I had x squared. What do I need to multiply by x squared to get negative x squared? I need a negative 1. So I'm going to put a negative 1 on top. Then I'm going to multiply negative 1 times x squared is negative x squared. Negative 1 times 3 is negative 3. That I'm going to write that underneath the 1. I'm going to subtract. So that means I have to distribute the negative. When I distribute the negative, that changes into a plus, and that as well changes into a plus. The negative x squared and plus x squared terms are going to cancel. The 2x is just going to come down because there wasn't any x terms that we subtracted. And then 1 plus 3, that's going to give me 4. At this point, there is nothing else for me to bring down, so this is going to be where I stop. I just have to write down my answer now. So my answer is going to be the quotient, which is what I have on top, 2x squared minus 3x plus 1, minus 1 rather. 2x squared minus 3x minus 1. And to that, I'm going to add the remainder, which was 2x plus 4. I'm going to put the remainder over the divisor, which is x squared plus 3. And that's my answer for this long division. Next, I'm going to show you how to divide polynomials using synthetic division, which is this other method. Now, you may see after I've showed you how to do synthetic division, you may realize that that's actually easier, and a lot of people usually tend to like this method better than long division. So let me show you how to do this. So before you do this, first of all, there are 3 things that we need to check. So again, we have to make sure the terms are arranged properly from the biggest power down to the smallest power. If there are any missing powers, we have to put a zero term for it. And then finally here, there is one more condition, and that says the divisor must be in the form x minus c. So what does that mean? It means that the divisor has to be in the form where it's x minus a number, or it could also be x plus a number, okay? You could even have something like maybe let's say 2x minus 1. That could also be your divisor, okay? Or let's say 3x plus 2. That can also be your divisor. But the main thing is that in your divisor, you can only have x, okay? It can be x squared, it can be x cubed. It has to be something where it's just x, okay? So like I said here, x minus a number or x plus a number, You can also have a number with the x, but as long as it's just x. That's the main thing, okay? All right, so let me show you how to do this. So here we want to divide 4x cubed minus 28x minus 7 by x minus 3. So again, notice my divisor is x minus 3. So you just have an x, which is good. So here, I'm going to need to rearrange. Actually, I don't need to rearrange, but I need to include an x squared term. So that's going to be 4x cubed plus 0x squared minus 28x minus 7. That's my polynomial. Now let me show you how we're going to set this one up, okay? The setting up of the synthetic division is very different from long division, okay? So what we're going to do first is we're going to look at the coefficients. What I mean by the coefficients are the numbers that are in front of your x's. We're going to write those numbers down. So just the numbers, okay? So 4, 0, negative 28, and negative 7. Okay? Next, in front of this, I'm going to do something like this. And in front is where you would usually be putting the divisor. So in this case, my divisor is x minus 3. What I'm going to do with the x minus 3 is that I'm going to set it equal to 0, and I'm going to get x by itself. So that's going to tell me x is equal to 3. I'm going to take the number 3 that I got from x by solving x, and that's going to be the number that's going to go in front. I'm going to leave a space underneath these numbers, and I'm going to draw a line. This is how we set up the synthetic division. Now, here is how we actually do the division process. The first number that I have, the 4, is simply just going to come down, and I'm going to put 4 down there. What I'm going to do next is I'm going to multiply 4 times 3. Okay, so I'm going to multiply these numbers together. 4 times 3 is 12. And what I'm going to do is I'm going to put that number right here underneath the 0. Okay, so 4 times 3 is 12. 12 is going to go here. What I'm going to do with the 0 and the 12 now is I'm going to add these together. So 0 plus 12 will give me 12. Next, I'm going to multiply 12 times 3. 12 times 3 is 36. So this 36 is going to go here underneath the negative 28. And I'm going to add negative 28 and 36 together. That will give me 8. And then finally, I'm going to multiply 8 times 3. That's 24. Now I'm going to add negative 7 and 24. That's going to give me 17. All right. So that is synthetic division. Now, with what the numbers that I've gotten here, okay, the very last number, the 17 in this case, that number is always your remainder. So if you remember, when we write down our answer, we have to put the remainder over the divisor. So when I write down my answer, the 17 will have to go over the divisor. So the original divisor was x minus 4 or x minus 3. So at the end, I'm going to have x minus 3 for my answer. So 17 over the divisor. Now for the other part of the answer that's going to go in front of that, I'm going to get that from these numbers that I have down here. So the 4, the 12, and the 8. What's going to happen here is that the 8 is going to be a number all by itself, okay? The 12, you're going to put an x with it, and then the 4, you're going to put an x squared with it, okay? So this is all by itself. This will have an x, this will have an x squared. If you had other terms, it will go x cubed, x4, x5, and so on, okay? So in this case, though, we only have 3 things. So the 8 goes by itself, and then the 12, we're going to put an x with it. And then the 4, we're going to put an x squared with it. So there's our answer. It's 4x squared plus 12x plus 8 plus 17 over x minus 3. So this is how you divide polynomials using synthetic division. So as you see here, it's not as much work. Okay, the work is easier than if you had done this using long division. Here's another example. This is my polynomial. So first I'm going to have to rearrange this. You also notice here that there's not an x squared term, so I'll have to include an x squared term. So when I rearrange this, it's going to become 2x power 4 plus 7x cubed plus 0x squared minus 3x plus 5. Okay, now to set up the synthetic division, I'm just going to look at the coefficients. The coefficients, like I told you earlier, are the numbers that are in front of the x terms. I'm simply going to write those numbers down, just the numbers, as I'm doing right here. And then in front for the divisor, so my divisor here is x plus 1. What I have to do with the x plus 1 is I'm going to set it equal to 0, and I'm going to get x by itself. So this gives me x equals -1. That's the number that I'm going to put in front. I'm going to leave a space and draw a line. Now we're ready to go with our synthetic division. First, I'm going to bring the 2 down. Now I'm going to multiply 2 times -1, which gives me -2. And then I'm going to add these numbers. So 7 minus 2 is 5. 5 times -1 is -5. 0 plus -5 is a -5. -5 times -1 is a +5. -3 plus 5, that will give me 2. 2 times -1 is a -2. 5 plus a -2 is 3. 3 is the last number. That number is my remainder. So the remainder will go over the divisor, which was x plus 1. That's what the divisor is. So when I write down my answer, at the end I'm going to have 3 over x plus 1. And then the other terms that will be in front of my answer are going to come from these numbers here. So here the 2 will be by itself, the -5 will have an x, the 5 will have an x squared, and then the 2 will have an x cubed. So it's going to be 2x cubed plus 5x squared minus 5x plus 2 plus 3 over x plus 1. And that's my answer for this long division. If your remainder was a negative number instead of a positive number, then we would just be subtracting it here at the end. And if they are a positive number like we found here, then we add them at the end. Next, we're going to talk about something called the remainder theorem. So the remainder theorem, like the word says, remainder. So it's something that we can do to figure out what the remainder is. Okay, so the remainder is basically, the number that we get at the end when we do the synthetic division. Or even if we do long division, okay, so we have a remainder at the very end. So there is a way for us to figure out simply what the remainder will be. And you can find the remainder by simply just evaluating the function. So for instance here, if my function is x4 plus x cubed minus 6x squared minus 5x minus 15, and I ask you to find f of 5. So this is something that you should know how to do at this point. So f of 5, when I ask you to evaluate f of 5, that just means you're going to plug in 5 for x. So you can do this on your calculator where you're going to replace every x with 5. And we're going to see what that gives us, okay? So in this case, that's going to give me 560. So the number that I get when I plug in 5, that number tells me what the remainder would be, okay? So this 560, that is my remainder, okay? Now, what is this a remainder of? So it's basically telling me that if I were to do, let's say, synthetic division for this function right here, okay? So let me just set it up and show you. Okay, so I would have a 1, because I have 1x4, and then another 1 for the 1x cubed, and then a -6 for the x squared, and then I have -5, and then -15. Okay, so if I were to set up a synthetic division like this with 5, in front because it says f of 5, and you went through the whole process, at the very end, where the remainder is, you would get 560, which is the number that we got here. Okay? You could do this on your own if you'd like to, the synthetic division right here, but I'm just gonna skip it for now. So same thing here, if I ask you to find f of -3, that means you're just gonna plug in -3 for x. So you're gonna replace each x in the original function by -3. Then you're gonna figure out what that comes out to. You will see in this case that if you were to replace x with -3, that will give you 0. So in this case, you get a remainder of 0. Okay, that's your answer. It just tells you what the remainder is. That's why it's called the remainder theorem. Now, if you recall from the previous section, we had discussed what a 0 for the polynomial is. So the 0 is basically the x-intercept on the graph of the polynomial function. So one of the things we're going to relate to here is how when you do synthetic division, if you get a remainder of 0, what that tells you, it tells you that the number that you divided by is a 0 of your polynomial. Okay? And actually, it was mentioned right here in the notes for the remainder theorem. So if you get a remainder of 0, then this number c is a 0 of the polynomial. So the examples that we're going to do next are examples where I'm going to give you a number and we want to see if that number is a 0 or not. So to figure out if that number is a 0, we just got to figure out the remainder, and we want to see if we get a remainder of 0. Now, to get the remainder here, we're actually going to use synthetic division. Okay, it is possible for you to just plug in the 2 and get your answer, but we're going to do synthetic division here because for once, I want you to be familiar with synthetic division and understand how to do it. And then secondly, the thing about just plugging in the number is that it will give you the remainder, yes, but then it doesn't give you the other part of the division, which we are going to need to use for things later on. All right, so it's best to just stick to using the synthetic division to get the remainder. All right, so here is my function, 2x4 minus 3x² plus 5x minus 11. So if I want to get the remainder here, I'm going to have to first make sure that my function is good to go. So everything is arranged properly, but you notice that there is not an x³ term. Okay, so I'm going to have to include a 0x³ term in my function. So now I can set up my synthetic division. So I'm going to put 2, 0, -3, 5, -11. And the number that I would like to check here is the number 2. So that's the number that I'm going to put in front. Okay. Notice that they've already like solved for the x here, so you just use that number and plug it in. All right, so I'm going to leave a space and draw a line. This number 2 just comes down. Then I'm going to multiply 2 times 2 is 4. 0 plus 4 is 4. 4 times 2 is 8. -3 plus 8 will give me 5. Remember, you have to add these numbers. 5 times 2 is 10. 5 plus 10 is 15. 15 times 2 is 30. -11 plus 30, that gives me 19. 19 is the very last number. That's my remainder. It's not a 0. It's not 0. So because my remainder is not 0, that means that 2 is not a 0. Okay? We wanted to see if this number was a 0, and the number that they gave us here was 2. It did not give me a remainder of 0, so that means 2 is not a 0. In other words, 2 is not going to be an x-intercept. So here is another example. My function is 2x³ plus 5x² minus 14x minus 35. this polynomial is good to go. It's arranged properly. All the terms are there. So I'm going to write 2, 5, negative 14, negative 35. And then the divisor number is going to be square root of 7. Okay, so you can do this synthetic division with numbers such as square root of 7. It works the same way, but it is a little bit more complicated. And I'm going to show you how you do this. All right, so first I'm going to bring down the 2. So the 2 is going to come down. Now I'm going to have to multiply 2 times square root of 7. Well, 2 times square root of 7 is simply just going to be 2 square root of 7. So I'm going to write that right here underneath the 5. So that's going to be 2 square root of 7. Next, I have to add 5 plus 2 square root of 7. Well, the thing is that I'm not able to combine these two numbers together, okay? So when I add them, I'm just going to have to leave it as 5 plus 2 square root of 7, okay? You just write it like that, 5 plus 2 square root of 7, because you cannot combine these terms together. What I have to do next now is I have to multiply the 5 plus 2 square root of 7 times square root of 7. So I'm going to do this on the side, okay? So I have square root of 7, then I'm multiplying by 5 plus 2 square root of 7. So I'm going to multiply these by just distributing the square root of 7, okay, to each term. So when I multiply square root of 7 times 5, that would just give me 5 square root 7. And then when I multiply square root of 7 times 2 square root of 7, so what's going to happen here is that, so I'm writing it down first. So I have 2 square root of 7 and then times another square root of 7. So the 2 square root of 7s, when you combine them together, remember, like when you multiply 2 square roots together, they're going to cancel out. The square roots cancel out. So square root of 7 times square root of 7 is just going to be 7. And then when you multiply that 7 times 2, that's going to give me 14. So I have 5 square root of 7 plus 14. So that is what I'm going to put right here in my synthetic division. 5 square root of 7 plus 14. Now I have to combine the negative 14 and the 5 square root of 7 plus 14. You'll notice when I combine these two numbers together, the negative 14 and the positive 14 are going to end up canceling out. And what I'm going to get is simply 5 square root of 7. Now what I have to do is I have to multiply the 5 square root of 7 times the square root of 7. So when I multiply 5 square root of 7 times the square root of 7, okay, because remember when you do synthetic division, you multiply the number on the bottom by this number out here. So square root of 7 times square root of 7 will give me 7. And then 5 times 7, that will be 35. So I'm going to put the 35 here underneath the negative 35. And then when I add negative 35 and 35, you see that I get 0. This number is my remainder. And I do get a remainder of 0. If you get a remainder of 0, that tells you that your number is a 0. So in this case, we're going to say that square root of 7 is a 0. All right, let's do another one. This next one, the number that we're going to use, you notice is 3 plus I. So with I, what we have here is what we call an imaginary number. So let me remind you real quick first what I is. So in math, if you see I, like I said, this represents an imaginary number. And I is the same thing as the square root of negative 1. If you may remember, we've discussed before how we cannot take the square root of a negative number. That's because when you take the square root of a negative number, you get something that's imaginary. So because the square root of negative 1 is something that's imaginary, we use the letter I to represent imaginary. So that is what I is equal to. The I is the same thing as the square root of -1. Now, if I were to do I squared, meaning what I'm going to do is I'm going to square the square root of -1. So remember, like if you square a square root, the square and the square root cancels out, and that's going to leave me with simply just -1. Okay, so if you have I squared is equal to -1. So I'm going to put this here as a little note, and you will see that this is going to come in handy when I do the example. Okay, so remembering that I squared is equal to -1 is going to come in handy. All right, so let's go back to my example here. This is my function x cubed minus 7x squared plus 16x minus 10. This polynomial here is written in the correct order. There are no terms missing. So I'm going to go ahead and set up my synthetic division. And then my divisor in front is going to be 3 plus I. All right, first I'm going to bring the 1 down. Next, I'm going to multiply 1 times 3 plus I. So 1 times 3 plus I is just going to be 3 plus I. Now I have to add these together. Remember, we add them when we do synthetic division. So -7 plus 3 plus I. So what I can do here is I can combine the -7 and the 3. That will give me -4 and then plus I. Now I have to multiply -4 plus I times 3 plus I. I'm going to do that on the side. -4 plus I multiplied by 3 plus I. So I'm going to get this, multiply these together by foiling. So that's going to give me -12 minus 4I plus 3I and then plus I squared. That's the same thing as -12 minus I plus I squared. Now, remember, up here we talked about how if you have I squared, that's the same thing as -1. Okay, so I can write that as -12 minus I plus a -1. So if I combine the -12 and the -1 together, that's -13 minus I. So when I multiply -4 plus I times 3 plus I, that gives me -13 minus I, which I'm going to put it over here underneath the 16. Now I have to combine 16 plus -13 minus I. So here I can combine 16 minus 13 together. That gives me 3. And then I still have the minus I. Next, I'm going to have to multiply 3 minus I times the 3 plus I. So again, I'm going to do this on the side. 3 minus I times 3 plus I. We're going to FOIL. So 3 times 3 is 9. And then it will be plus 3I, and then minus 3I, and then minus I squared when you FOIL these two terms, these two things. The 3i's are going to cancel in this case. Remember, I squared is the same thing as -1. So I can write that as 9 minus a -1. 9 minus a -1 is the same thing as 9 plus 1, which gives me 10. So when I multiply 3 minus I times 3 plus I get 10. I'm going to put the 10 over here in my synthetic division. Now you see when I add -10 plus 10, that's going to give me 0. That's my remainder, and I get a remainder of 0. So if I get a remainder of 0, that tells me that this number that was in my divisor is a 0 of my polynomial. Okay, so that's how you determine if it's a 0 or not. You're going to do synthetic division, and you want to see if you get a remainder of 0. For the last part of this section, we're going to look at another theorem here called the factor theorem. So the factor theorem kind of goes along with the zeros. Before I do this, let me remind you of something that we had discussed in the previous section. So in the previous section, we had talked about how to find the zeros. So we found the zeros by having to factor our polynomial. Okay, like we have to get our polynomial in factored form. So something in factored form would be maybe like something like this. Okay, this is something in factored form. What we had to do next is to find the zeros of this. We would set each of these factors equal to 0. So x plus 1 is equal to 0. And then we'll get x equals -1. Or we would set x minus 2 equal to 0. And we'll get x equals 2, right? So then we had -1 and 2. Those are what we called the zeros. So what we've been doing here, we've been talking about how to figure out if a number is a 0. Okay, so let's say I had found out like the number 4 was a 0, for example. So if I knew that 4 was a 0, if I had to write that as a factor, the factor for that would be x minus 4. Okay, because if I have a factor of x minus 4 and I get the x by itself, that's going to give me x is equal to 4, which tells me that 4 is a 0. Okay, so it's basically kind of going backwards from what we did in the previous section. So in the previous section, you had your factors and you had to find your zeros. Now we have the zeros, we want to write them as factors. Okay, so it's going backwards. So if I tell you that 4 is a factor, if I tell you that 4 is a 0, then the factor would be x minus 4. If I say -2 is a 0, then the factor for that would be x plus 2. Okay? So that's what I mean by factors. So here, I give you some factors, and I'm asking you to tell me, well, I'm actually asking you to see or to verify that these are actually factors of this polynomial that I give you. So how we are going to do this is we are going to do synthetic division with these things here that could potentially be factors, and we want to see if we get a remainder of 0. Okay, so we want to see, is the remainder equal to 0? If you get a remainder of 0, then it's going to be a factor. If you do not get a remainder of 0, then it's not going to be a factor. All right, so here is my polynomial. Everything is arranged properly. No terms are missing. So I'm going to go ahead and jump right into the synthetic division for it. So I'm checking here if x minus 1 is a factor. So if I get the x by itself, that's going to give me x equals 1. So that's going to be the number that I'm going to put right here. I'm going to do the synthetic division. So bring down the 2. 2 times 1 is 2. 7 plus 2 is 9. -14 and let's see. Sorry. So -14 plus 9, that would give me -5. -5 times 1 is a -5. -40 and -5 is -45. -45 is my remainder. That is not 0. Okay, since it's not 0, this means that x minus 1 is not a factor in this case. Next, they want me to see if x plus 4 is a factor. So again, I'm going to do this by doing synthetic division. If I get the x by itself here, that's going to give me x equals -4. So I'm going to set up my synthetic division with -4 in front. It's the same function. So 2, 7, -14, -40. I bring the 2 down. 2 times -4 is -8. 7 minus 8 is -1. -1 times -4 is a +4. -14 plus 4 will give me -10. -10 times -4 is a +40. -40 plus 40 is 0. So here I do get a remainder of 0. If I get a remainder of 0, then that tells me that this x plus 4 is a factor. Okay, so again, you just want to do synthetic division and you want to make sure that you end up with a remainder of 0. The very last example here, I give you 3 zeros. So my zeros are 1/3, square root of 3, and negative square root of 3. And what I want you to do is I want to write the polynomial for this, okay? So the polynomial is like the original function, okay? Like this right here, this is a polynomial. It's a term, it's a function where you have all the terms listed out. So what we're going to do here is we're going to start from the zeros, and from the zeros, we're going to write down what the factors are. Okay? So now, going back to my explanation of factors earlier, so let's say if one of my factors was 2x plus 1, okay? Remember, one factor. Okay, let's say one of my factors was 2x plus 1. So if one of my factors is 2x plus 1, I want to get x by itself. Okay, so I'm going to set it equal to 0, move the 1, and then divide by 2. That's going to give me x equals 1/2. All right? So if my factor is 2x minus 1, the 0 is going to be 1/2. That's for a factor of 2x minus 1. So if right here, my 0 is 1/3, to write down the factor for 1/3, it's going to be 3x minus 1. Okay, because if I have 3x minus 1, and I set that equal to 0, that's going to give me 1/3 when I solve for x. Next, my 0 was square root of 3. So for that one, my factor, I'm just going to write the factor as x minus the square root of 3. Because if you write it like this and you try to get the x by itself, that's going to give me x equals positive square root of 3. And then for the last one, I have negative square root of 3. So the factor for it would be x plus the square root of 3. Okay, so I write it as factors. Now to get my polynomial, what I'm going to do is I'm going to FOIL. The thing is though, because I have 3 things that I need to FOIL here, I'm going to have to do 2 at a time. And I'm actually going to do these 2 together first. Okay, so I'm going to FOIL. And I'm going to FOIL those 2 terms together. When you FOIL these 2 terms together, it's going to FOIL to x squared minus 3. Okay, I trust that you can do FOILing at this point, so you can do the FOIL on your own, and you'll see that it's going to come out to x squared minus 3. Now, what we have left to do is we have to FOIL x squared minus 3 with the 3x minus 1. So, again, I'm going to FOIL. So here when I FOIL, that's going to give me 3x cubed, and then minus 9x, and then minus x squared, and then plus 3. The last thing I'm going to do, so this is actually my answer. This is my polynomial function. But what I'm going to do is I'm just going to rewrite it to where I put it in order. Okay, so my polynomial function here is going to be 3x cubed minus x squared minus 9x plus 3. This is what the original polynomial was, where these are the zeros for this polynomial. And that's the end of this section.